Ladies and gentlemen, welcome back. Today we are going to take a closer look at the algorithms and machine learning, what they are, how they differ, and how both can be used effectively in our medical affairs work. So this will be a very interesting comparison. In medical affairs, one of our most important responsibilities is to generate meaningful medical insights. And we generate medical insights from data, facts, and observations collected by our teams. These come from MSL interactions with healthcare professionals, from advisory boards, from scientific congresses, and other channels. Then we analyze all of this information to identify certain patterns and to transform it into actionable strategic insights. But there is a major challenge that we faced since years ago. These insights are often scattered, unstructured, and difficult to use sometimes. Difficult to use in a consistent strategic way. I remember that years ago, we used to receive the feedback that the field medical team are providing insights regularly, but they never knew what the organization is doing with these insights. And of course, there was a question about how valuable these insights were. So if these insights remain scattered and unstructured, it will be very difficult to use them in a consistent strategic way. That's why over the years, we evolved from using simple Excel sheets to smarter customer relation management systems with relatively advanced dashboards, filters, and structured fields. And while these CRM or customer relationship management systems have been useful to an extent, especially for storing the information, reporting safety concerns, and approving the insights, they are still very traditional tools. They serve the basic needs, but they don't go much further. And for so many years, that was enough for us as medical affairs. But times have changed, and with the evolution of our operating model and the evolution of the entire medical affairs, and the rise of digital channels, the volume of information we receive today is by far larger than ever. The risk of missing an important signal or emerging trend or a potential opportunity is now significantly higher. That's why we need platforms powered by artificial intelligence. We can no longer rely on sheets or traditional CRM systems, which are still Excel-based dashboards or static reporting tools. We need systems that really helps us make sense of the complexity, detect patterns that we may not see, and support better, faster decision-making. And now, when we look at the artificial intelligence-powered platforms available today, we can group them into two main categories. One, the algorithm-based platforms, and two, the machine learning platforms. Across the pharmaceutical industry, leaders in medical affairs are now racing to adopt one of these two technologies. Everyone wants to maximize the value of the medical insights coming from the field, and they wanted to make faster, smarter decisions based on these insights. But there is a key question: which one to choose? Which type of platform is truly right for medical affairs and for the nature of the work in medical affairs, when the goal is to capture, understand, and use medical insights effectively? This is not a technical discussion about which system is better. It's an important conversation for MSLs, medical managers, medical advisors, and also for senior decision makers in medical affairs who need to invest in the right tools for their teams. In order to answer this question, let's start from the basics. Traditional algorithm-based tools are exactly what they sound like. They are systems that follow strict rules, preset logic, or specific keywords. And I like the word keywords because it describes it very well. A simple example most people know is social media. When you post using certain keywords, the algorithm pushes your content to users who follow or engage with the same keywords. If you don't use the right keyword, the algorithm simply ignores your content. It doesn't understand your message. It only responds to the labels you give it, which is the keyword. Now, let's translate it into our world in medical affairs. And algorithm-based systems behave the same way. You tell them what to look for, and they search for exactly that. Nothing more, nothing less. For example, if an MSL writes the keyword efficacy anywhere in his text, the system flags it as an efficacy concern. If the word evidence appears, the system knows that it will automatically mark it as an evidence generation opportunity. For example, if the MSL types safety, the system tags it under safety issues. If the note contains the keyword adherence, the system will push it to the patient support or compliance bucket, and so on. It is clean, predictable, and very easy to implement. But one major limitation here, given the nature of how we collect data, facts, observations, and then transform them into medical insights. If you use an algorithm-based platform or tool, you get out what you explicitly put in. Nothing more, nothing less. This creates a big gap between the people who design the system around specific keywords and the users, who may not always write those keywords in the same way or might not even be aware of these keywords. So what happens? If an MSL forgets to type the keyword or writes the observation as free text, for example, the valuable insights may never be captured, flagged, or acted upon. Let's think about it with few examples. Instead of the keyword efficacy, an MSL might write patients are not responding well. The algorithm will not catch it as an efficacy concern. Instead of adherence, the MSL can write patients are skipping doses. The system here will not recognize this pattern. Instead of safety, an MSL might write patients complained of burning sensation after the injection. Here again, the algorithm won't know that this belongs to the safety category. And this is where algorithm-based tools fall short. So yes, these platforms are useful for routine, very structured tasks like automatic flagging, compliance alerts, basic reporting, checkbox-style data entry. But what they cannot do is to understand the way you naturally speak, the way you write, the tone, the context, and the meaning behind the words. They don't interpret, they only match. And in medical affairs, where insights are often complex and highly contextual, that becomes a real limitation. And this is exactly why when decision maker chooses an algorithm-based platform, a system that depends entirely on keywords and predefined rules, there will be always a need for human oversight. Because the platform only recognizes what you tell it to recognize. Someone must manually review the insights it captured, the patterns it missed, the notes that were not tagged correctly, and the free text entries that the system couldn't interpret. This means additional time, additional resources, and ultimately additional cost. Even with a well-designed algorithm-based platform, you still need a trained colleague, often a medical manager, an MSL lead, or an insights specialist to clean the data, fix the misclassifications, and make sure nothing important was missed or overlooked. So instead of freeing up capacity, the system actually creates more work, especially when the volume of insights grows. And in fast-moving therapeutic areas, those delays can mean lost opportunities, missed safety signals, or slower strategic responses. Now, on the other side of the spectrum, machine learning platforms work in a completely different way. Unlike algorithms that follow fixed instructions and certain keywords, machine learning systems learn from your data. They can read free text notes, pick up weak or emerging signals, spot trends that you never defined in advance, and identify patterns across hundreds, thousands, or even millions of medical interactions. They don't wait for keywords. They don't rely on checklists. They actively try to understand what's being written, the tone and the context, the meaning, and even the subtle shifts in clinical practice. One of the best and simplest examples is a tool many of us already use, ChatGPT. If you have interacted with ChatGPT, you know exactly what machine learning looks like in real life. You don't need to tell it which keyword to look for. You don't need to follow a rigid structure. You simply write your question in your own words and it understands you. And the more you interact with it, the better it becomes. It learns your style, your patterns, and the context of your questions. And over time, its outputs become more accurate and relevant and more helpful, hopefully. That ability to learn, adapt, and improve is exactly what differentiates machine learning from traditional algorithm-based systems. Let's look at few medical affairs examples to make this even clearer. Imagine an MSL writes the following free text note. Dr. Sarah mentioned she's seeing a drop in the patient response to second-line biologics among younger female patients. The traditional algorithm-based system would miss most of this. It will not understand the context, it will not recognize the demographic detail, and it will not see the clinical relevance unless the exact word efficacy was typed. But on the other hand, the machine learning platform reads this note in a very different way. It will analyze the language and immediately identifies multiple layers of meaning. Like, for example, this is an efficacy concern. It is specific to a demographic subgroup, which is the younger female patients. It relates to second-line biologics, indicating the treatment sequence pattern. It could be part of an emerging trend across other geographies, and it may require medical or strategic escalation. This is the power of machine learning. It doesn't sit and wait for the MSL to click the right box or type the predefined keyword. It understands the message, even if the wording changes, even if the phrasing is unique, and even if the pattern is just beginning to emerge. Although machine learning platforms may come with a higher initial investment, the long-term benefits of these platforms far outweigh the upfront cost. Once implemented, machine learning systems drastically reduce the ongoing workload by removing the need for manual review, the need for keyword monitoring, or repeated data cleaning. They save time, reduce reliance on manpower, and eliminate constant effort required to correct traditional algorithm outputs. More importantly, the overall value of medical insight rises dramatically because the system captures the context, the early signs that keyword-based tools consistently miss. And when we look at the regional or global levels, the advantage becomes even greater. A machine learning platform can connect patterns and detect correlations across thousands of interactions gathered by hundreds of MSLs in different countries and regions. Spotting shifts in clinical practice, emerging concerns, unmet needs, and new opportunities long time before a human team could connect these signals together. In short, the system pays for itself by scaling intelligence, predicting patterns across different markets, and unlocking insights that traditional algorithms were never designed to see even. If you ask my honest recommendation, and if the goal is to truly maximize the value of the entire insight generation process, then I would, without any hesitation, and absolutely will choose the machine learning system. It is the only approach that elevates insights beyond the basic reporting and turns them into really meaningful intelligence. But the decision is not always as straightforward as it seems. Choosing between algorithm-based and machine learning platforms depends on the organizational readiness, the maturity of its digital infrastructure, the available budget, of course, and the strategic vision of the leaders. Some teams may start with simpler systems because they are familiar and easier to adopt, while others may be ready to invest now in the scalability and long-term efficiency that machine learning provides. The key is understanding that this is not just a technology choice. It's a choice about the level of insight, accuracy, and also the strategic clarity you want to unlock across all your organization. Ladies and gentlemen, as the volume of scientific interactions we do continue to grow, the way we capture and interpret insights will define how quickly and accurately we can respond to emerging needs across different markets. So whether our teams are just beginning their digital transformation or already operating across multiple regions, choosing the right system is a strategic decision, a very strategic decision. Machine learning platforms offer the level of depth, speed, scalability that traditional tools simply cannot match. And as our roles evolve in medical affairs, the ability to recognize early signals, connect patterns across geographies, and transform observation into real intelligence becomes very important factors. I hope today's tutorial has given you some clarity, and I look forward to seeing how you apply these concepts in your daily work and future leadership decisions. Until next time, take care and keep learning.